This video demonstrates the operation of the Mix-ORB Tangible User Interface for multi-track audio mixing in the digital audio workstation. The interface approaches the task of mixing in an alternative way, presenting a more tactile and metaphoric interface which encourages the engineer to have more understanding of sonic spatialization, panorama and depth. Key features of the interface include a tangible user interface which controls volume, pan, processing and effects with a single hand control, referred to as a puck, for each audio track up to a maximum of 8 tracks. A graphical user interface that is a 3D metaphoric visualization of a stage, with colour-coded orbs to represent each audio track in the virtual space. A touchscreen for visual feedback and additional controls for the interface and connected DAW. The control panel is used to display active control pucks and track naming. By clicking on the track name input in the control panel GUI, you can name each track. This is then displayed in the track name section on the touchscreen and above the orb in the stage display. The crosses to the left of each track name display active pucks in the session. By clicking on any of the right hand boxes, this kills the orb and removes it from the stage display. The stage display represents each track as a sound source in a 3-dimensional virtual space. When a colour-coded puck is placed on the tangible control area, the equivalent orb will appear on the stage display. The track name is continuously displayed above each orb and the selected process or effect is displayed below. By placing a second puck, the corresponding orb will now appear. Note that the process and effects name has now disappeared from below the red orb and is now displayed below the green. This is to highlight which orb is currently being controlled in the stage display. The tangible control area is the main section of the interface. It detects the pucks when placed. This area allows the control of 3 parameters: volume, pan and effects levels for each track. By pushing the puck away lowers the level. This simulates the sound source being further away in a virtual space. Pulling the puck towards you raises the level. Again, this simulates the sound source getting closer to the listening position. Moving the puck left and right will steer the sound source between the left and right stereo channels. Rotating the puck controls the amount of the processing or effects selected on the touchscreen display. By rotating the puck clockwise raises the amount and anti-clockwise lowers the amount. Because a single puck has the ability to control 5 processes and effects, a rotation system has been employed to make this section of the interface as user-friendly as possible. When the puck is rotated and a value is set for the selected process or effect, this amount is stored. When the next process or effect is selected, the puck will need to be rotated to match what amount is currently stored in the system. This can be seen on the circular amount indicators on the touchscreen display next to each process or effect. The line on the puck will guide the user to this stored amount. Only when the rotation angle of the puck equals this stored amount, the data being controlled by the puck will be engaged and pass through to the corresponding process or effect. This is highlighted by the circular indicator on the touchscreen being updated and the halo around the orb in the stage display. The system has been implemented so the user can adjust each process and effect amounts throughout the mixing process by using only one control. The touchscreen display does two functions. It displays information about each track and provides extra control functionality for processing and effects, control data, the stage display, door channels and transport controls. Each track display is divided into 8 pages, which can be viewed at any time by selecting the tab at the top of the display. The pages are also selected automatically when an active puck is moved on the tangible control area. The height control alters the height of the orb on the stage display. This allows for the stage display to be easier to view when a number of pucks are active. This can also be used as a guide when mixing to illustrate the frequency of the instruments in the session. For example, a kick drum will be placed lower, as this sound contains low frequency characteristics. The interface has the ability to control 5 different processes and effects by rotating the puck. This is governed by the effects selector on the touchscreen panel as to which of these 5 options the rotation of the puck is controlling at any one time. As an amount is dialed in on the puck, the display on the touchscreen highlights the amount set next to the selected process or effect. Mute controls are available next to each process or effect to switch off or back on when required. The volume pan and effects lock buttons switch on and off the control data for the selected puck. This allows the user to move the puck to control volume and pan without altering the selected effects or vice versa. You can lock all 3 parameters so the puck can be removed from the table to allow other orbs to be positioned in the same place. The solo and mute buttons control the solo and mute on the corresponding track in the DAW. Transport controls are available at the bottom of every page for each track on the touchscreen display. Play and stop controls playback of the project, and the RTZ, which stands for return to zero, returns the project to the very start. The use of having one hand control that operated 3 different parameters made the interface very intuitive to use. Part of the aim in the development of the interface was to resolve some of the issues revealed by previous academic research. One of these aspects was the way the system presented layers of data and cues to the user. By using a mixture of the stage display and visual feedback from the touchscreen display and its page function, the interface was very easy to control and navigate between the different functions available and track information. The interface was found to be very reliable, and only once throughout the testing did the system detect a puck incorrectly. This was due to light levels in the room the interface was placed. From a professional perspective, a system with at least 24 tracks will be required. The pucks would have to be reduced in size and would lead to additional development in the table design and lighting of the tangible control area for the system to detect the fiducial markers correctly. The interface is suitable for the novice user, especially in understanding sonic spatialization. The desk could be adapted for live and theatre use, and future work could include the interface being adapted for surround sound.